Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss some MCQs of chemical reaction engineering. So let's start. Which one of the following are two different species? Which of the following are two different species? This is ethine and this is also ethine. This is the condensed formula of ethine. This is the structural formula of ethine. This is the uh, this is ethene double bond carbon 2. This is also ethene. Here the CH3 and H group, and here is H and CH3. This is one species. Here CH3 and CH3, H and H. So this is another species. So these C and D are two different species. So this is the correct option. The rate dash on type of reactor. The rate does not depend. So the rate does not depend on type of reactor. So the rate does not depend on. So for CSTR and PFR, the rate in Britain is KCA. So this is for PFR, CSTR and any other reactor. So rate doesn't depend on the type of reactor. The following general material balance equation on a system is: this material balance, which is input minus output plus generation minus consumption, is equal to accumulation. This is the general material balance equation from stoichiometry. The general material balance from stoichiometry is this. Which of the following is the basic equation of chemical reaction engineering? Fa0 minus Fa. Fa is the molar flow rate of component A minus Fa, molar flow rate of component A at any other time. This is at initial time, this is at any other time. This is the rate of A, this is the change in volume, this is the change in mole of A per unit change in time. So this also change the molar flow rate of component J. This is molar flow rate of component J at any time. This is rate of component J. This is change in volume, change in the mole of A with the passage of time. So this is the general basic equation of general mole balance equation. The general mole balance equation. This is the mole balance equation of CRE, chemical reaction engineering. The general mole balance equation of component J is this. So this is the general mole balance equation, and this equation is also a general equation, but it is for component A, and this is the general mole balance equation for any component. The J can be A, B or C or any other component. For batch reactor, which usually used for testing new material, the general mole balance equation will be. So in batch reactor there is no input, no output, so input and output are 0, so this will be equal to this. So RA into change in V and V is equal to NA by dt. Yes, rate is constant, then RA into V NA divided by dt. Yes, this is dt and V. This is rearrange this, and R come to the denominator, so dNA by RA, and we know that minus RA is equal to KCA. So all of them are correct. CSTR is normally used for gas phase reaction, liquid phase reaction, both none of them. CSTR is usually used for the liquid phase reaction. The batch reactor is usually used for gas and liquid reactions. Similarly, the PFR and PBR reactor are usually used for the gas phase reaction, and CSTR are used for the liquid phase reactions. The design equation for the ideal CSTR is at steady state is input minus output plus rate of A change in V is equal to change in the at steady state. At steady state, the change in mode of A with the passage of time will be 0. So at steady state, this term will be 0 and this term will occur. So at steady state, this is accumulation term is 0, and we can rearrange this. If A not come to this side, if A come to this side, and the rate is also constant, and to dV, integrate dV, it will be equal to V, and it is equal to 0. So this is Fa0 minus Fa, and V, this is the constant rate of A, RA, and we integrate this, it will be equal to V is equal to 0. Yes, this is also, these two are the design equation for CSTR. Now rearrange this equation. If A will come to this side, if A not come to this side, and RA will come to the denominator, and this is the volume of the CSTR. Yes, this is also the general equation for the CSTR. Now rearrange this equation. It will also give us volume. Yes, all of them are the design equation or design equation of the CSTR. Molar flow rate and molar concentration are related to. So Fa is the molar flow rate, Fa, C is the concentration, and V is the volumetric flow rate. And Fa, molar flow rate of component A is equal to concentration of A into the volumetric flow rate of A. So Fa is equal to Ca into V. Fa mean mole per unit time, concentration mean mole per unit volume, and volumetric flow rate mean volume per unit time. So this cancel with this. Mole per unit time is equal to C into Ca into volumetric flow rate. So this is Fa is equal to Ca into mass flow rate. Fa is equal to C into V. No. Fa is equal to Ca into volume per unit time, volumetric flow rate. Yes. So both A and D are the correct option. Tubular reactor PFR and PBR are used for liquid phase reaction, gas phase reaction, slurry. As we have already discussed that PFR and PBR are used for gas phase reaction. So this is the correct option. The differential form of PBR is RA is equal to DFA divided by V. So this is the steady state. The differential form of the PBR will be what will be the differential form of the PBR? So the differential form of PBR will be equal to RA is equal to DFA and 2V change in the molar flow rate of A with the change in volume. Yes, this is the design equation of PBR. Ideal PBR reactor. Ideal PFR mean plug flow reactor. RA is equal to Ca into V. Yes, Fa is equal to Ca into V. So in place of Fa we will write Ca into V. This is the volumetric flow rate. If volumetric flow rate is constant, that will come out from the differential, and it will be dCa by dV RA, all of them. So all of them are the design equation of the PBR. The completion of a reaction doesn't depend on the shape of reactor, volume, rate of reaction, so shape of the reactor. So thank you very much.